Hello everyone, welcome back to another video covering AP CSA, and today we'll be covering Unit 7 of AP CSA, which is about ArrayList. My name is Tianling Cheng, and you can also call me Rain, and today we'll be going through what is an ArrayList, access and modifying ArrayLists, methods, and some example problems. Now firstly, what is an ArrayList? An ArrayList is a class in Java that represents a resizable array-like data structure. It provides a way to store and manipulate a collection of objects. Compared to arrays, it is easier to add and remove objects from the array list. Objects could be added and removed without concerns associated with the resizing or shifting of elements. And this is an example of an array list being structured out. It looks really similar to an array and it acts in sort of the same way, but there are some fundamental differences in these two. And now, how to create an array list. And in Java, we declare an array list by calling the keyword ArrayList. We then specify the object type in the pointy brackets that follows it. And followed by that, we'll be naming the array list. And then we'll call the assignment operator and the new keyword and repeating the ArrayList keyword and the object type inside the pointy brackets, and then followed by that an empty parameter. And below is a screenshot of what it looks like. So first we will be calling the ArrayList keyword, then we'll be adding or specifying the object type in the pointy bracket, and by adding integer, we are declaring that this array list will be containing integer objects only. And then I've decided to name this array list num, and you can also name it other names by your wish. And we'll use the assignment operator, the equal sign, and the new keyword, followed by the keyword ArrayList, integer in pointy brackets, and also it is very important to add the empty parameters, or else this function would not operate properly. And now to access an ArrayList. Now ArrayList will share the same index as the array system and also the string system, and so the starting object or the first object of an array list will always have the index of 0. So most of the techniques that worked with arrays associated with length and indexes would also work with array lists. Now, if you're trying to review for APCSA, you'll find that there will be several ArrayList methods that are listed on your reference sheet, unlike arrays wherein there's no methods listed. And the first one you see would be size with an empty parameter, and the return of this function would be an int type. Now, this function will return the amount of object in an array list, and therefore the length of the array list, if you look at it as an array. And the second one would be add, and inside a parameter with the object that you want to add to the array list, and it will return true if the object has been added successfully. And for the third void function, which means that there will be no returns, you have two parameters. You have two indices inside the parameter. The first one is the index at int type, and the second would be the object. And this function would add an object at the given index and given +1 to all objects behind it. And if you can't comprehend it at this moment, that would be fine, because we'll be giving some examples of it in the following PPTs. And the fourth function would return the object at a given index, and so, but do bear in mind that you have to use the correct index, or else the return would be wrong. And for the fifth function, we will set the given index to the object and return the original object. It's sort of like replacing the object in an array list and returning you the original object or the object that has been replaced. And for the last function, we will be removing the object at a given index and returning the objects, and also be minusing 1 to all the object that follows it. Now in this slide, I'll be showing a very long example of how to modify an array list. And if you're trying to review for your AP exam, or if you're trying to check your understanding of this unit, I would strongly recommend you to pause this video, grab a piece of paper, and traverse through each line and try to predict what each print method will return you with. And now I assume that you have already前面全剪掉。And now I assume that you've already attempted this question yourself, and I'll be traversing through each line with you guys together. And for the first line, it's an assignment operator, which we mentioned 2 slides ago. And what this line basically does is we declare a new array list of integer type, and we're naming the array list num. And for the first method that appears in this class, we'll find that number 1 has been added to the array list. And since there's only one parameter, it will be automatically added to the end of the list. But since the list have no numbers here, 1 will be added to both the back and the front, which is index 0 of the array list for now. And therefore, if we print out the return of the getting the index 0, we'll receive the answer 1, which I think is a pretty easy question and that most of you should get correct. And for the second method, we'll be adding 2 to the end of the array list, since there are also only one parameter. And now this array list should consist of 2 numbers, both of numbers 1 and number 2. And therefore, if we print out the size of the list, we should get the answer 2, because there are now 2 objects in this array list instead of only 1. And for the next line, although my IDE kind of gave it away with the index and the element symbol, and I apologize for it, but this function, or this method actually, adds 3 to the array list at the given index 1, and moves all objects behind it 1 backwards, which means that they give a +1 to their indexes. And just like I mentioned when I was talking about the reference sheet, in this, and if you couldn't comprehend it back then, here could be a visual example. So by adding 3 to the index 1, and do bear in mind that 2 was at index 1 before this method, so now instead of 2 being the second object, 3 becomes the second object, and 2 gets pushed behind, sort of, giving a +1 to its index. So now 2 instead have the index 2 instead of 1. And 3 becomes a new index 1. That makes sense. And therefore, if we print out the whole array list, and do bear in mind that because although the size of the array list is 3, but the index of the last object, or the ending index, should be -1 of the length. So 3 minus 2 would be, 3 minus 1, sorry, would be 2. And therefore, by printing 2, you'll be printing the last object. And so by printing this, we should receive the answers 1, 3, and 2. And the next function, next method, I apologize, would set index 2 to 4. And although it will return the replaced index, so in this case it will be 2, but because I didn't use a print function here, it will not show in the results, but sometimes it could be helpful to know this fact while you're writing your FRQ, and just do bear that at the back of your mind while you're doing the questions. And so by setting index 2 to the number 4, we'll now have the new array list, which will look like 1, 3, and 4. And if we remove the index 0 now, and this method would also, though it will also return the removed index, so in this case 1, but because I didn't use a print function, it will also not show, but do also keep in mind that it will be compiled through your IDE or your examiner. And if we remove 1 from the array list, this array list will now look like 3 and 4. And therefore, if we print out the indexes 0 and 1, we'll be receiving the answers 3 and 4. But what if we print out the methods, instead of only printing out the indexes 0 and 1, we now print out the indexes 0, 1, and 2, while there's only 2 objects in this array list? Well, as a lot of you might have expected, there'll be an out-of-bounds error. And that's why, while we're using methods associated with ArrayList, we have to be very careful about the index system. And if we use the wrong index, an error would occur, which messes up your whole function. And so for some key takeaways for this method or presentation, firstly, the size of a list is not fixed like an array. So as we've seen in some of the examples, the objects can be moved around automatically while objects are replaced or actually removed or added, while in arrays they'll be fixed. And when the object at an index gets removed, the object behind it moves up to take its spot, and while it's added, it will push the objects behind it backward. And therefore, you should be very careful of the index system so you do not trigger an out-of-bounds error. Now, though traversing through an array list is similar to an array, I do still again feel the importance to mention it in this slide. So here in the example, I've created a new array list of integer type called num, and I've added 4 objects to the num, each consisting of numbers 1, 2, 3, and 4. And to traverse through this array, I personally would like to use for loops, but enhanced for loops could also be used. And in some occasions also while loops as well, but sometimes while loops do not work as intended. So I would personally prefer for loops and enhanced for loops. And so to look at this example, I first created a new object of int type and set it to 0. And then I've given the condition for I less than num.size, which in this case was 4. So I, in this case, will traverse through indexes 0, 1, 2, and 3, which are integer numbers smaller than 4. And I've given the condition I++, which means that after each cycle, I will be given 1 more to its value. And for this function inside the for loop, it will print out the object inside the num list at the given index I. And since the values of I will each consist of 0, 1, 2, and 3 through the 4 cycles, it will print out the indexes of 0, 1, 2, and 3, which in this case would be the whole array list. And therefore this traverse will be successful, and will print out 1, 2, 3, and 4 as its return. And now here's a practice question that to check your understanding of this PPT that we've just went through. And you can pause the video now to attempt it while I will be discussing this question with you after your attempt. Okay, so now I assume that you have already attempted the question, and I'll be going through this question with you guys. So firstly, in this question, we have created a new array list of the following integer values: 0, 0, 4, 2, 5, 0, 3, 0. And we have been given a function or method that has been ran, and we want to predict the final outcome of this method. And so let's first look at the function or the method itself. We can see that there's a while loop inside the method, and instead of k smaller than num.size, I'll prefer to write out nums.size equals 8, so I know that k will be less than 8. And since k equals to 0, there will be a total of 8 times that this while loop would be ran before it stops. And the if statement checks if the object at the given index k is equal to 0. And if that is, the object would be removed from the array list. And the k++ runs, make sure that all the integer elements are traversed. And therefore, this method traverse through all the array list and delete all zeros? So would the answer be D? Let's traverse through this question again. So in the first cycle, num equal to the array list num would equal to 0, 0, 4, 2, 5, 0, 3, 0 initially. And when k equals to 0, num dot get k would equal to 0 because it's the first element. And therefore the dot equals 0 will return true. And therefore num.remove k would be activated, and now the new array list would look like 0, 4, 2, 5, 0, 3, 0, with the first 0 being deleted, and with k++, k would equal to 1. However, if you check the second cycle, though the nums still have 0 at its first index, but because k is now equal to 1, num.get k would now equal to 4, and the first 0 have been skipped, and therefore the dot equals would be false, and an object gets skipped because of the change in index that array lists have that arrays don't. And with that 0 skipped, it will not be traversed, and therefore it will not be checked, and it will not be removed. So the answer is actually 04253, which is the given answer E. And here is a credit to all the sources that I've used, and thank you all for watching my video. Bye bye.